All right, today's integral is a bit of a weird one. We have the integral of x plus 1 minus e to the negative x, all multiplied by e to the x e to the x. Now, this integral is really, really weird. It's not immediately obvious what to do. I originally tried a u substitution, letting u equal x e to the x. That didn't work out. But then I noticed we have this random negative exponent of e to the negative x here. So negative exponents aren't typically great, so why don't we just factor that out? See what happens if we take this out. So I'm going to factor out an e to the negative x. Factoring negative exponents isn't that nice, but this is just going to turn into x e to the x plus e to the x minus 1. And then again, we still have this e to the x over here, and dx. What I want to do next is I see we have an e to a power multiplied by e to a power. Because they're the same bases, I could combine them to have just one base with the more powers, whatever. So I'm going to keep this big mess all right here. And then combining the powers, I'm going to leave it as e to the x, and I'm just going to add on this minus x dx. And now something you might notice is this whole thing, the power inside the e, looks very similar, if not the same, as the derivative, or the derivative of this thing, this power of the e, looks very similar to this part, is what I'm trying to say. So let's take the derivative, see if it's similar or exactly the same. So I'm going to let u equal x e to the x minus x. Therefore, du is going to equal, we have to do product rule first, so that's going to turn into e to the x plus x e to the x. And then deriving minus x is just minus 1, and then dx. So notice we have an e to the x, we have an e to the x. X e to the x e to the x, and minus 1, minus 1. So this whole chunk is exactly the same right here, so we have a perfect u substitution. So we're going to have the integral of e to the u, and then this whole chunk right here, that is our du. So it's just integrating e to the u du. We know the integral of e to the u just equals e to the u. Back substituting u equaled x e to the x minus x. So e to the x e to the x minus x is our final answer. Just getting it in terms of the way MIT had it in their answer. They just factored out an x, so it'd be e to the x times e to the x minus 1. Now that's our final answer. It's an indefinite integral, so don't forget your plus c. And that is it.